Hello students, today I am taking this lecture on Boolean algebra basics. Okay, so in this lecture I am going to tell you about Boolean postulates and law, and I will tell you the mnemonics, means how to memorize them in your mind so that when there are exams you can easily write them in your answer sheet. Okay, so before start I will like to tell that basic logic gates is the prerequisite of this lecture, and this lecture is intended with exam point of view, means when you are writing your exams, then how to memorize the various postulates of Boolean algebra in an organized way. So for that purpose I will tell you the mnemonics so that you can easily recall the Boolean postulates in your mind. Okay, and you may find it funny but can be helpful to memorize. Okay, so first of all you must keep in mind that Boolean algebra is applicable for binary number system in which 0 and 1 are used. So if a variable a is there, when we are using variables in Boolean algebra, then if a variable a is there, then it can attain value of either 0 or 1. And if a is considered 1, then a complement will be considered 0. Means a dash you can apply as well as bar can also be applied. But if you are considering a to be 1, then a complement will be 0, and vice versa. Means in case you are taking a complement to be 1, then a will be considered as 0. Okay. And to an AND gate, if AND gate is there, then if all the inputs, say a1, a2, a3 up to an, if all the inputs are 1, then only the output y will be 1. In case y I am taking as output, it will be only 1 in case all the inputs are 1. So the Boolean expression for AND gate is a1 into a2 up to an, it will be multiplied equals to y. Okay, so in this case, if any one variable attains 0, suppose I say a2 is 0, it is irrespective of other variables are 0 or not, it will make 0, because 0 into anything is 0. Similarly, to an OR gate, okay, at least one input must be 1. Means if there are A1, A2, A3, A4 like these inputs are, then at least one of the variable input must be 1. Then only the output Y will be 1. Okay, so the OR gate expression can be written as A1 plus A2 ultimately up to plus AN equals to Y, because in case any one variable attains 1, then it is irrespective of other variables are 1 or not, it will make 1. Okay. Now you have to memorize the following statement. This is a phrase, meaningless phrase. However, just to develop the mnemonics of Boolean postulates, you have to, as it is, keep in mind. Comp is indoor, Cadira is outdoor. Comp is indoor and Cadira is outdoor. Here, indoor pronunciation is like same that of indoor, but you have to keep in mind indoor. Okay, and in this phrase, only red expressions are useful, other are just to make the sentence. Only this comp, andor and kadira will be used. Now from here, comp stands for complement law, which says that if you are adding a with its complement, this is actually the case of OR gate. So if you are adding a with its complement, you will get 1. Okay, similarly, complement rule for this AND gate is if you are ANDing a with its complement, a dot a complement, it is equals to 0. So it is very simple to learn that in case a is added to a complement, in that case if a is 0, a complement will be 1. So 1 plus 0 will be 1. Similarly, if a is 1, then a complement will be 0. Okay, then also it will be 1. And in this case, for multiplication, if any one of the two is 0, the output is 0. Okay, so if a is 1, a complement will has to be 0. So 1 into 0 will be 0. Okay. Now comp we have done. Now AND OR. So AND OR means AND rule says, I have already told that in case it is an AND gate of two input, then you will write the output y equals to a dot b, and OR rule is y equals to a plus b. This we have already talked. This is the case of two input OR gate. Okay. Now for this Kadira, let's take C. C is commutative law. Okay, which says that if A is added to B, then it is equals to B is added to A. Either A comes first or B, it doesn't matter. Similarly, for this case also, A dot B equals to B dot A. A plus is for OR gate and multiplication is for AND gate. Okay, so how to memorize this? That in a community, it is commutative law. You can memorize like this, that in a community, people have mutual understanding. A has mutual understanding with B, then B will have mutual understanding with A. Similarly, for here also, AND gate, A mutual understanding with B, then B will also have mutual understanding with A. Okay, this is the case of commutative law for OR gate, and this is the case of commutative law for AND gate. Now, Cadira A, we will take A. Associative law says that if there are three variables and we are adding those A plus B and C, so either you add A plus B first and then add to C, or add B plus C and then add it to A, it makes no difference. Okay, so how you will memorize this? That being friends, suppose A, B, C are friends, then either A is associated with B, A is talking with B, or B is talking with C. Okay, it will not make any difference. So this is associative law. A is associated with B, or B is associated with C. Okay, addition will remain same. Now distributive law, Kadira's D I am taking. So distributive law says that A into B plus C is equals to AB plus AC. It means we can easily open the bracket. Okay, means AB plus AC is equals to, in case I am keeping this B plus C in bracket. So how you can remember this thing? See, if A comes to the home of B and C and delivers food or delivers them separately, it makes no difference. Like this, this is the, this bracket is the home of B and C. So A comes and delivers food to B and C or distributes them separately, it makes no difference. So Kadira's D we have learnt. Now idempotent rule. It says A plus A means A is odd with A is equals to A, or A dot A is also A. So A is ANDed with A, it is A. Okay. You can memorize like this: idempotent and identical. Words are of almost same pronunciation. So identical persons can be considered as one and unique. Means if there are identical persons, okay, then you can consider them as one. So A plus A is A dot A is also A. Now redundant literal rule, which says that A plus A complement B is equals to A plus B. Okay, this is A, this is A complement, and this is B equals to A plus B. The redundant literal rule you can memorize like this: that literally negativity of person doesn't affect other. So literal is over here in literal rule. So literally negativity of person doesn't affect other. So you can consider that A complement is negative of A. So A complement is not affecting B. So it is equals to A plus B. There is a proof also. See, this A plus A complement B can be written as A dot 1. Means A is ANDed with 1. So in case 1 is ANDed to any variable, it will make no difference because 1 into A will be A itself. Okay. So A dot 1 plus A complement B. Okay. Now this 1 can be written as 1 plus B. This is a case of OR gate. Because in case of OR gate, if any one input is 1, then the output is 1. So A into 1 plus B plus A complement B. Now in case you are opening the bracket by distributive law, so A plus AB plus A complement B. Now from here we can take B common, so inside it A plus A complement. So A plus A complement is 1, we know this thing, so that is equals to A plus B. Okay, this is redundant literal rule and we have worked for this R. Now A at the end is absorption rule. Okay, which says that A plus AB equals to A itself. You can memorize like this: A goes, eats up B, absorbs B, and then comes back. It remains A. A goes, absorbs B, and then comes back. So A plus AB equals to A itself. So there is a simple proof. You can take A common. So inside the bracket 1 plus B. So this is 1 plus B is actually a case of OR gate. So if 1 is added to any variable, it will give 1. So that is equals to A itself. Okay. So by this small lecture, you would have learnt about the Boolean postulates as well as how to memorize them in your mind so that in exam you can easily write down in the answer sheet. Thank you.